Hi dear students, welcome to Geeta's classes. So in this class we are going to see some more equations which can be reduced to exact differential equation. So in part 1 we have seen two models, that is equation reducible to exact differential equations means what? If you can write, if the given differential equation is formed only by differentiating the given relationship between y and x, not without performing any other operations, then it is called, that is if you can write the given equation as the differentiation of some function, then it is said to be exact. How will you find out whether it is exact or not? The condition to find out is if the equation is of the form m dx plus n dy is equal to 0, then dou m by dou y is equal to dou n by dou x is the condition, necessary and sufficient condition for the given differential equation to be exact. Okay, and sometimes if it is not equal, then it is not exact. There are some equations which can be reduced to exact equations. How will you reduce that? You have to find the integrating factor. What do you mean by integrating factor? It is a function of x comma y. You have to find a function of x comma y. If you multiply this integrating factor with the given differential equation, that equation will become exact. Okay, so there are rules for finding these integrating factors. Type 1 and type 2 we have completed in the previous class. First, type 1 is by inspection or regrouping, and I gave you some formulas you have to remember. And type 2, homogeneous equations. If you are not able to regroup them, then go for checking whether it is a homogeneous equation or not. If it is a homogeneous equation, then the integrating factor is 1 by mx plus ny with the denominator not equal to 0. That is an important condition. Okay. Next is type 3. Type 3 is integrating factor for an equation of the type. If the given equation is of this type, f1 of x comma y and y dx plus f2 of xy into x dy is equal to 0. If the equation is of this form, if the given differential equation is of this form, then 1 by mx minus ny is the integrating factor where the denominator not equal to 0. What do you mean by f1 of xy? See, suppose you have x squared y squared, then I can write it as xy the whole squared. Suppose if you have x cube y cube, then I can write it as xy the whole cube. Suppose if you have sine of x squared y squared, that means sine of, you can write sine of xy the whole squared, right? Sine of xy the whole squared, that is a function of xy. Is x squared y, if you have this, is it a function of xy? No, because you cannot write. If you can write the given function as xy the whole part, then we say that it is a function of xy. Okay, so every term it should satisfy. Apart from this function of xy, the remaining you must have y dx and x dy, right? So if the given equation is of this form, then you can say that you can find out the integrating factor as 1 by mx minus ny. Okay, so if the equation is not satisfying exact, then type 1 it is not coming under type 1, or type 2 then you have to go for type 3. Yes, now 1 plus xy, is it a function of xy? Yes, of course. Don't ask, can you say that 1 is a function of xy? Yes, of course. You can write x power 0, y power 0 is 1, right? So you can write it as a function of xy. It is a function of xy. So this is a function of xy and y dx plus another function of xy and x dy is equal to 0. So it is coming under type 3. So what is the integrating? Now what is m here? So m is equal to 1 plus xy or y plus xy squared, and n is equal to x minus x squared y, right? Therefore mx integrating factor is, you can check that, you have to show that dou m by dou y not equal to dou n by dou x. I'll show that also. Dou m by dou y is equal to 1 plus 2xy, right? And dou n by dou x is 1 minus 2xy. They are not equal. It is 1 plus 2xy. This is 1 minus 2xy. So they are not equal. Therefore not exact. Therefore not exact. Now cannot regroup, if you can regroup them, fine. Otherwise, whichever is easy, whichever method you feel easier. The same problem can be done by different methods. No issues in that. You can follow whichever method you are comfortable with. Okay. So now integrating factor is, it is of the form type 3. It is type 3. It is of the form f1 of xy into y dx plus f2 of xy into x dy is equal to 0. So here integrating factor is 1 by mx minus ny, right, which is equal to 1 by, what is m, y into, so xy, if you multiply xy plus x squared y squared minus of 1 minus y into, so xy plus x squared y squared. So xy and minus xy will get cancelled. You will be getting 1 by 2x squared y squared is our integrating factor. Then what is the next step? We have to multiply the given equation by the integrating factor. So multiplying 1 by 2y squared by the integrating factor 1 by 2x squared y squared, we get, what is the first term? 1 plus xy into y dx divided by, so if you simplify, you will be getting 1 by 2x squared y squared, here y plus xy squared, yeah, y plus xy squared. So 1y will get cancelled, so 1 by 2x squared y. What is the next term? Next term is xy squared, right? So divided by x squared y squared, so 1 by 2x into dx is equal to 1 by, what is n? X minus x squared. So x means 1 by 2xy squared minus 1 by 2y into dy is equal to 0, right? Which is an exact equation. After multiplying the integrating factor, it will become exact. Therefore, the solution is 1 by integral of m dx. So 1 by 2x squared y plus 1 by 2x. If it is exact, we know how to do that, right? Into dx, keeping y as constant, plus integral of terms of n not containing x. It is only minus 1 by, so I will change this as minus 1 by 2y into dy is equal to constant. This is the solution. So 1 by 2y, it is a constant, I will take it outside, and 1 by x squared. 1 by x squared means what? X power minus 2, right? So x power, integral of x power minus 2 dx will be x power minus 2 plus 1 by minus 2 plus 1. Whatever you are writing in the power, so this will be minus 1 by x power 1 by x power minus 2 plus 1, it will become x power minus 1 divided by minus 1, that is minus 1 by x. Okay, so minus 1 by x, or I will write it in the bracket so that it will be clear. So minus 1 by x plus 1 by 2 into x. 1 by x is log x, integral of 1 by x is log x, minus 1 by 2 into log y is equal to c. That is log of, I am combining these two. So throughout you can multiply by 2. Okay. So log of, combining these two, log of x by y minus 1 by xy is equal to c1 or c dash. 2c actually, you can write it as c dash. This is the c dash or c1, any other constant you can write. Okay. Then next is type 4. So if the what is type 3? If the given equation is of this form, f1 of xy into y dx, f1 of xy into y dx plus f2 of xy into x dy, then what is the differential, what is the integrating factor? 1 by mx minus ny. Okay. Next, type 4, in the equation m dx plus n dy. Suppose if it is not possible by all the above three methods, above three types, it is not coming under any of the previous three types, then go for checking these things. Dou m by dou y minus dou n by dou x divided by n is equal to, check this value, check for this value. If you are getting a function of x alone, then the integrating factor will be e power integral f of x dx. Okay. If instead of this, dou n by dou y divided minus dou m by dou x divided by m. Please remember always m for x, n for y, remember like that. Okay, m of xy and m dx plus n dy is equal to 0. That is the given differential equation, right? In this, always try to relate m with x and n with y. And what is the condition for exactness? Dou m by dou y. Ulta, you have to multiply the other variable. In the same way, dou m by dou y minus dou n by dou x divided by. If you start with m, you have to write the other variable in the denominator. So remember like that. N, dou m by dou y minus dou n by dou x divided by n. N means dou m by x. Here again, opposite only, n f of x alone. Okay. Then integrating factor, whatever you are getting here, e power integral of this function into dx will give you the integrating factor. Similar way, dou n by dou y minus dou m by dou x divided by m is equal to g of y. It is a function of y alone. Then whatever you are getting here, that should be written in the power, e power integral of this function into dy. If it is a function of x alone, you have to integrate with respect to x. If it is a function of y alone, then you have to integrate with respect to y. Okay. So this is our integrating factor. Let us see problems. Solve xy squared minus e power 1 by x cube into dx minus x squared y dy is equal to 0. Okay. So now what is m? This is our m, right? M is equal to xy squared minus e power 1 by x cube is our m. And what is n? Minus x squared y, right? What is dou m by dou y? 2xy. With respect to y, you are differentiating. Therefore, you have to treat x as a constant. So, second term will become 0. What is dou n by dou x? Again, minus 2xy. They are not equal. Of course, they are not exact. Now, let us find out dou m by dou y. No hard and fast rule that you have to follow this method only. You have to start from this only. Nothing like that. Whichever method you feel comfortable. If you are getting the answer, fine. So 2x minus of minus 2xy divided by n is what? Minus x squared y is equal to, here minus of minus, so 4xy divided by minus x squared y. So x squared, y and y will get cancelled, x squared and 1x will get cancelled, minus 4 by x is the integrating factor. So integrating, no, this is not integrating factor. This is a function of x alone. So this is a function of x alone. Therefore, the integrating factor is equal to e power integral of whatever function you are getting, minus 4 by x into dx. Because it is a function of x alone, you have to integrate with respect to x. Okay. So e power minus 4 into log x. Right. So I can write this as e power minus 4 minus log x power 4, or e power log of x power minus 4. E and log inverse functions, therefore you can write it as x power minus 4, or you can say 1 by x power 4. 1 by x power 4 is our integrating factor. This is the integrating factor. So now you have to give this equation number 1. So multiplying throughout by multiplying 1 throughout by the integrating factor. What is the integrating factor? 1 by x power 4, right? 1 by x power 4 we get first term is what? xy squared by x power 4. So y squared by x cube minus 1 by x power 4 into e power minus 1 by x cube. E power 1 by x cube into dx minus y by x squared into dy is equal to 0, which is exact. In the exam, you can prove depending on the marks, okay? Depending on the marks, if it is for 5 marks, you need not prove this. If it is for 7 or 8 marks, you can prove this is also exact. Therefore, the solution is integral m. So m dx. Therefore, integral y squared by x cube minus 1 by x power 4 into e power 1 by x cube into dx plus here for n you have x, therefore there is no term, therefore it is equal to c. So this can be written as y squared is a constant, keeping y as a constant, don't forget to write that, okay? That is y squared into x power minus 3 means minus 3 plus 2 divided by minus 3 plus 2, okay? So minus 3 plus 2 is minus 1, so minus y squared into x power minus 2 divided by 2 plus 1 by 3 into integral of e power minus x cube, x power minus 3, right? X power minus 3 into minus 3 x power minus 4 into dx. I am rewriting this. 1 by x power 4 is there, no? So x power minus 4, because I have minus 3 here, if the differentiation is here, then it will be easy for me. So what are all missing here? 3 is missing, right? Minus 3 is missing. So I am going to, here already we have one minus, therefore it becomes plus, and 1 by 3. I am multiplying and dividing by minus 3, okay, is equal to constant. According to the requirement, you should be able to adjust that. E power minus x power minus 3 I have. So minus 3, if the differentiation is what? E power, minus 3 into x power minus 3 minus 1. So minus x power 4. Here we have 1 by x power 4. 1 by x power 4 is x power minus 4. Only the constant is missing. So that is to be multiplied and divided by. Okay. Therefore, that is 1 by 3 into e power minus x cube minus 1 by 2 into y squared by x squared is equal to constant. This is the answer. Okay. If you don't understand any step, please post it, I'll explain. Okay. Next is one more problem. Solve y log y dx plus x minus log y into dy is equal to 0. So m is equal to, what is m here? Y log y. And n is equal to x minus log y. What is dou m by dou y? Y into 1 by y, right? Plus log y into 1. Differentiating partially with respect to y. So y and y will get cancelled. You will be getting 1 plus log y, right? And dou n by dou x is 1. Now you consider dou n by dou x minus dou m by dou y divided by m. There is no hard and fast rule that you have to start with this only. Okay, just by applying the methods, just to try to apply each and every one. You cannot say that you have to solve by this method directly, nothing like that. They will not mention also. Okay, so whatever you are convenient with, you can write. So dou n by dou x is 1 and minus of 1. So minus 1 plus minus log y, right? Minus log y. Dou m minus of, so minus of minus, it will be plus, yeah. Yeah. Divided by m is what? Y log y. So 1 and 1 will get cancelled. You will be getting log y and log y will be cancelled. Minus 1 by y. It is a function of y alone. Is a function of y alone, right? Did I miss one? Minus. Correct one. Minus 1 by y. Now, what is the integrating factor? According to the formula, e power integral of whatever function you are getting. So, minus 1 by y into dy, right? That is equal to e power minus of, what is the integral of 1 by y? Log y. So, log y is equal to e power, this minus I am bringing here, y power minus 1. E and log of inverse functions. So, y power minus 1, that is 1 by y again. So, 1 by y is our integrating factor. And let the given equation be equation number 1, multiplying 1 by y. Multiplying throughout by 1 by y. The integrating factor. What is the integrating factor? 1 by y. We get log y into dx. 1 by y, it is y into log y is our m. Therefore, y and y will get cancelled. Plus 1 by y into x minus log y into dy is equal to 0. Okay. Therefore, this is exact, which is exact. Always remember, when you multiply the integrating factor with the given equation, definitely it will become exact. If you check if it is not exact, that means it is a clue for you that you have made a mistake. Okay. Therefore, the solution is integral log y dx plus minus log y. Here the first term contains x, so don't consider, only the second term. So minus log y by y integral of into dy. Here you have to treat y as a constant is equal to c. Therefore, when you integrate with respect to x, so therefore x in log y is a constant and minus here log y and 1 by y. You have like this integral of log y and the differential of this is 1 by y. Therefore, you can write log y the whole square. So, minus 1 by 2 into log y the whole square is equal to constant. This is the answer. Okay. So, with this, all these reducible forms are over. Next is linear differential equation. Before that, let us recollect whatever we have studied. Exact means you know the meaning of exact differential equation, and the condition for the given differential equation is dou m by given differential equation is exact is dou m by dou y is equal to dou n by dou x. This is the condition, and the solution is given by integral m dx keeping y as constant plus integral of terms of n not containing x dy is equal to c. All these things you have to remember. That is why I am rewriting this. Okay. And non-exact means you can reduce it to exact. Find the integrating factor. Integrating factor should be multiplied with the given differential equation to make it exact. Multiply the given differential equation to make it exact. So first type we have seen by inspection or regrouping, and please try to remember the formulas. Okay. So type 2 is homogeneous equation. If you are not able to regroup them, then check whether it is a homogeneous equation or not. If it is a homogeneous equation, then the integrating factor is 1 by mx plus ny, so that, and the denominator not equal to 0. Mx plus ny not equal to 0. And type 3, if the differential equation is of the form, if it is not a homogeneous equation, then check for the next one. If it is of the form f1 of xy into y dx plus f2 of xy into x dy is equal to 0, then the integrating factor will be 1 by mx minus ny, okay, with mx minus ny not equal to 0. And type 4, in the equation mdx plus ndy is equal to 0, if it is not coming in any of the first 3 types, then check for the Next one, dou m by dou y minus dou n by dou x divided by n is equal to function of x alone. Then e per integral of this function dx will give you the integrating factor. Similarly, dou n by dou y minus dou m by dou x divided by m is equal to function of y alone. Then e per integral of this function into dy, because it is a function of y alone, into dy will give you the integrating factor. Okay, so that's all with the exact differential equation. And next is linear equation, Leibniz linear equation. We'll see in the next class. Thank you for listening.